Level 2, number 4. So a cyclist drives off a cliff. So essentially we're talking about two positions. The top of the cliff, which we'll call position 1, and the bottom, as just before hitting the ground, position 2. So at the top of the cliff, if you think about the energy they have two kinds of energy. Well, actually, maybe not. Let's read the question. They definitely have EG, gravitational energy, because of their height. Now, the car drives off the cliff. It says that her initial speed is entirely horizontal, which means that her EK, at least in terms of moving downwards, is 0. Well, actually, in this case, the EK does have a value, just to kind of show you how when you overthink things, they get really complicated. The EK has a value here. Let's put a smiley face for the value. And then at position 2, the EK is going to have an additional value, right? It's going to be the EK from before, which is the smiley face. Let me just erase that for a second. Okay, it's going to be the kinetic energy from before plus the new kinetic energy that's going to be introduced as the height diminishes, right? As you fall downwards, you trade your height for speed. Now, in a case like this, we can not worry about this energy because it's not going to be part of the question. What we're really talking about here is we want to figure out how much of this height is going to turn into speed. So to keep it simple, because it's horizontal, we're going to ignore that. And we're talking about how fast she'll be moving towards the ground. Okay? So let's go back and erase some of that because it's complicating the issue. So let's just assume that the EK, at least in terms of movement in the up and down direction, there is 0. And then down below here, that is where she's going to have some EK. And so we just have to figure this out. And the way we do it is by using the law of conservation energy. The total position energy from any one position is equal to the total energy in any other position. In the first position, we're concerned with how much of that height energy, EG, turns into EK. And so we have mgh here, and 1/2 mv squared here. And all of these numbers are either given or can cancel out. And what you end up solving for is the v, which is how fast she would be moving towards the ground due to that height. So that's just a conservation